Hi everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over Ottocento number 17, Constants on Display. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay guys, first things first, there's some prior reviewing you're going to want to do to get the prerequisite knowledge to understand the problems in this video. First off, you're going to want to check out my Desmos course, in particular these three videos on intercepts, evaluating functions, and domain restrictions. And there are some common context for these types of questions is advanced exponentials. I actually have not a lot of people know about it, but I actually have a series of them, series of videos on this in my Shorts tab. So if you go to my Shorts tab and scroll down to like the middle, it's like probably I think it's somewhere like 20th in the playlist, something like that. I have three shorts on exponentials plus time. Please watch all of those before you watch the rest of this video. I'm not going to be teaching you the concept from this video, so please watch those first, otherwise it's not going to make any sense. And little disclaimer, answer choices for these questions, as you see, are very tough to write. So some of the questions are only going to have maybe 3 answer choices. That's not going to detract from the educational value. So please just be okay with there being 3 answer choices. I know that's not going to be like that in the SAT, but some of these questions I'm only going to write 3 answer choices just to save myself some time. All right. So what does it mean when a number is on display in an equation? Well, if you think about like how colloquially in English we use the phrase on display, it's often like a store display, right? Like usually like a mannequin with like clothing, and you kind of like walk by and maybe like a couple things that are on those mannequins or in that display jump out at you. Like right here, if I just take a quick look at it, I'm thinking like jacket, green shirt, blue pants, orange like skirt or pants, whatever that is, white shirt, things like that. I'm maybe not noticing finer details. Maybe if I look deeper, I can notice things like the buttons on the jacket and things like that. But like just at a quick glance, I just noticed these kind of like 5 or 6 things. So we're going to be kind of doing the same thing when we look at numbers in an equation for these types of questions on the SAT. So there's really only 2 steps, although these questions do get very hard because of the context that they ask you in. They ask you these questions in. So step 1 is to identify the number discussed in the question. And step 2 is to take a cursory glance at the function and see if you can find that number on display. So I actually think step 1 is the hardest. I think that is the hardest, me personally, is figuring out what number are they asking me about. However, I actually find via my tutoring that most kids can actually figure out what the number they're asking is. They just kind of go to do the final answer, and then the cursory glance part, they mess up. So I hope you guys you'll see as you agree with me, checking, oh, is this number on display, is kind of the hard part's coming up with the number. So hopefully you'll agree with me once you get familiar with the question type. All right, so this is a basic slide. I'm just going to identify some constants in these 2 functions I have up here. You'll notice both these, x is the variable. So x is not a constant, x is the variable. It's inside the function, f of x, g of x. So I'm just going to go left to right. So I see a 4, I see a 3, and I see a 5. Now, a lot of you are probably thinking, oh, wait, well, isn't that like a -5? And like, yeah, it kind of is, but it depends on what the parent form is. Is it like minus +5 or is it plus -5? Like, it kind of depends. So like, just don't worry about it. There's not going to be an SAT question where that matters. So just this is like the only time where I'm going to tell you, like, don't worry about the sign. So don't worry about the sign. So I see these 2 numbers, 4, 3, and 5. If the number the question asked me about was like an 8 or a 19, I would be like, okay, that's wrong. I don't see an 8 or a 19. But if it were like 4, then I would maybe mark that choice correct. Okay, let's look at the second one now. So a is a constant. It's not the variable, so it must be a constant. 3 is a constant that I see. B is a constant that I see. 9 is a constant that I see. X is not a constant, it's a variable. And C is a constant that I see. So in this function, I see A, 3, B, 9, and C. So if the value that I came up with was equal to one of those 5 values, then this answer choice would be right. But if it was not equal to one of those 5 values, then that answer choice would be wrong. And this will all make more sense once we do a practice problem in a second. All right, so this is my favorite question. Definitely pause the video and write this down. This is my favorite question to use this to teach students. Because the context is not that scary, right? The context is just, oh, we got to find a y-intercept, right? That's probably something, if you've been studying for the SAT for like a month, that's probably something you're familiar with at this point, right? So let's see, it says displays. So that's how I know it's this kind of question, is like it tells me, does it show or does it display the number we're looking for? And it talks about, as I was just mentioning, the y-coordinate of the y-intercept. Now, this question also says something else important. It says that all of the answer choices are so to find the y-intercept, we're going to graph it or set x equal to 0. For a y-intercept, x equals 0. For an x-intercept, y equals 0. You always set the other letter equal to 0. Now, this question also mentions that they're equivalent forms. So that means that all 4 of these functions are the same. They're just written differently. They don't look like they're the same. But if you plotted all of them, you would see that they're all the same. So it doesn't matter which answer choice I use to answer the question. So I am just going to pick one. So how about I pick answer choice A, because that's the first one. And A isn't necessarily going to be the answer, but it's going to be what I use to solve the question. All right, so I'll go on it. We'll graph it, and we'll also, plug in x equals 0. For y-intercepts, you can just use function notation. If you didn't know, the y-intercept is just equal to f of 0. So regardless, if you graph it or type in f of 0, you get 0.04. There's no decimals in this question, so the y-intercept is 1/25. I just clicked the fraction button there. And you see, regardless of which way we do it, we get the same thing. I would encourage you to use the function notation whenever possible, because it's really good at giving you the exact fractional value. Okay, so 1/25 or 0.04, but there's no decimal. So 1/25 is the number this question is asking us to look for. So now just look with your eyes and see which answer choice. This is the part that everybody gets confused on, right? Just look and see which answer choice has a 1/25 in it. And the only one with a 1/25 in it is D. I know that can seem kind of like, I don't know, maybe frustratingly straightforward, because the question is worded really confusingly, but that's all they wanted you to do, is identify the number and then pick out which function has that number in it. So that is answer choice D. And if you still don't believe me that A, B, C, and D are all the same function, I plotted all of them. They're all stacked right on top of each other. And you see, if I evaluate for the y-intercept, I get 1/25 each and every time. So if you said, Kyle, I don't want to use A, I'm going to pick another answer choice, you can do that. You would still get 1/25. Just remember, the function that you picked isn't necessarily the answer. That's just helping you learn more about these equivalent forms. All right, second question. We've gone over one just like this in the Desmos number 17 on domain restrictions. So pause this video, take a second to read it. I notice it says displays, so I kind of know what I'm getting myself into. And I notice it wants us to find the maximum value of the function. So the maximum y value, the highest point on the graph. And I also notice it gives us a domain restriction. 2 is less than or equal to x is less than or equal to 6. So when we go to type it into Desmos, we're going to use curly brackets so that it just gives us that piece of the graph so that it's easier to figure out. So each of these answer choices is totally separate. It says f of x and g of x. They are not the same function. So we need to very carefully consider each answer choice in a vacuum on its own. So just don't look at both of them at the same time. Let's just consider answer choice 1, just consider answer choice 2. They are not the same thing. The question doesn't mention their equivalent forms anywhere. All right, so I typed in the first one. You'll notice that I've used curly brackets to type in the domain restriction. And then just pretend that point isn't there. I just put that there for teaching. You don't need to put that point there. You'll notice that the highest point on the curve is on the right. And the rightmost x value is 6. So we're going to type into Desmos f of 6. Hopefully that kind of makes intuitive sense. And I didn't see any fractions in these choices, so I'll just leave it as a decimal, even though you could change it. I think it's 4/5. So we just figured out the maximum of f is 0.8. So I'm going to put a big box around that. That's important. All right. Now for g of x, we're going to do the same thing. Use the curly brackets to type in the domain restriction. But this time, I noticed the highest point is all the way on the left. So instead of typing in, the leftmost x value is 2. So instead of typing in like g of 6, kind of like we did before, I'm going to type in g of 2. So the maximum is g of 2, which is 2.25. So I'm going to put a big box around that. So the maximum value of f was 0.8. The maximum value of g is 2.25. Now we can go and put that on the question. And again, we're just going to consider each answer choice totally independently in a vacuum. So let's just look at answer choice 1. So, okay, I see a 2, I see a 0.4, I see a 4, and I see a 6. Don't see a 0.8 anywhere. This answer choice is wrong. It does not count. Now I'm going to look at the other answer choices. The other answer choice, I see a 16, a 2.25, a 0.5, and a 2. Well, we know the maximum was 2.25, and there is a 2.25 on display in this equation, so this answer choice is correct. So we're going to go with Roman numeral 2 only, which is answer choice B. All right, so you'll notice that these questions get a lot more complicated and annoying to look at as they start introducing more and more letters. I really did my best with this one, guys. Just trust me, these questions are really hard to write. So let's look at some of the key information. So they said A, B, C, and W are positive constants. A is less than B is less than C. It says, by the way, this is testing us on the exponentials plus time equation from my short. Y equals A times B to the x over n. And this wording here for each increase in the value of x by W, that is telling us the interval, which in my notes I use little n. So we just figured out that that guy is equal to W. And then increases by a factor of, that's just a fancy way of saying y got multiplied by this number. So b in the question is b in the notes here. So that's the multiplier. So the multiplier is b. So we're like, we want to get the question, and I see it's asking us something about W. So it's asking us something about the interval. So we want to get an answer choice that can quickly get it to look like, have a base, a multiplier of b, and an interval we can figure out. And I can pick whichever one I want because they're equivalent forms. So I'm just going to pick answer choice A because that one looks like the least confusing to deal with. So let's do that on the next slide. So I'm just going to take this one and make it look more like the equation from my notes in my YouTube shorts. So 1 over c times x, well, 1 times x is just x. So this gives you x over c. So the exponent can be rewritten as x over c. And you see if I rewrite the equation from the notes and hold it up next to it, you can see, oh, wait, this is good. The multiplier is B, and the interval is C. Oh, so we just learned something. Okay, so when the multiplier is equal to B, that's what the question wanted, that's a good thing, we conclude that the interval, which the question told us was equal to W, is also equal to C. So we just learned something really important. W is equal to C. All right, so the value, what was it, 3W over 2C? So 3W over 2C, you see this W and this C, they're equal, so they cancel out. And we're left with just 3/2 or 1.5. So we're going to go back to the answer choices and look and see if there's a 3/2 or 1.5 in any of the answer choices. And sure enough, it looks like there is a 1.5 in answer choice B. So the answer is B. Now, I know that was a lot at once, so I just want to assure you there's another way to do it. And I mean, for all these questions, even with constants, is you can just go to Desmos and come up with valid numbers. So pay attention. A, B, C, and W are positive constants, and A is less than B is less than C. So we can go to Desmos and just come up with whatever numbers we want, and we could use that to figure it out. So you'll see that's what I did here. So remember, they have to be positive, and they have to be A is less than B is less than C. So I made A equals 2, B equals 3, and C equals 4. And then they're all equivalent forms. You can use whatever answer choice you want. So I used answer choice C just to showcase that a different one would still work. And I started at a Y value of 2. And then when I multiplied it by B, I got a Y value of 6. So I increased it by a factor of B. And when that happened, I saw that X went up by 4. 4 minus 0 is 4. So that means W equals 4. And I noticed that 4 is equal to C. So now I'm like, is 4 always equal to C? Or is W always equal to C? Or is that just some kind of coincidence? And so what I did was I did it again. I didn't even really need to change anything. I just changed the top portion. And I tried to pick really random constants. So see, I made A equal to 5. I made B equal to 8 and C equal to 21. So I just tried to be as random as possible, but still valid, right? A is less than B is less than C, and they're all positive. And you see I did the exact same thing. I started at whatever Y was when X was 0, and then I multiplied it by a factor of B, and Desmos, it increased by 21, and C is equal to 21. So W and C, no matter what I make A, B, and C, that's probably always going to be true. So it's probably safe for me to assume that W equals C always. So what's the lesson? What is the takeaway? Don't mess with Maui when he's on our breakaway. This tapestry here on my skin is a map of the victories I win. All right, so anyway, the takeaway is if a display question has letter constants, you can invent valid numbers for the letters to help you solve it. And as you saw in the last example, even if you didn't really understand that stuff about exponentials, if you read the question carefully, picked valid numbers, and then like used your knowledge of like multiplication and subtraction, you probably could have still figured it out. So that's what I suggest you do, especially if you're stuck. And keep in mind, guys, we only did 3 examples, and we're going to do more on the worksheet, but so I'm going to just try to include more of them on the worksheet, but there's lots of context for this number they want you to find when they ask these questions. This isn't even all-inclusive. This is just a lot of the heavy hitters. You see a lot they ask about x coordinate of the x-intercept, y coordinate of the y-intercept, the multiplier, the interval, which is one we just did, slope, if it's a line, minimum, maximum. We did do a maximum, but we didn't do a minimum. So you kind of see there's all sorts of context for this. So you really need to have a deep understanding of these other common concepts and types of functions that are on the SAT, linear functions, quadratic functions, and exponential functions. in order to be able to tackle these questions. Now, certainly being really good at Desmos helps, but it's better if you have a deep understanding of those three types of functions. Okay, it's time for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. And I highly encourage you to ask relevant questions about this topic in the comments section. Let's go to the whiteboard for the final review. Okay, question 1. So first thing I notice is they want me to find the slope. They're all equivalent forms, so I'm going to pick any answer choice I want to work with. I'm going to go with answer choice B. So how about we do negative 6x plus 2y equals 10. I'm going to put this in slope-intercept form. I'm going to add 6x to both sides, and I get 2y equals 6x plus 10. And now I'm going to divide everything in the equation by 2. And I get y equals 3x plus 5. And it seems like, looking at the mx plus b form, that the slope is 3. So now I'm just looking at all those answer choices to see if there's a constant or coefficient of 3. And it certainly seems like there is in answer choice C. So that is the answer. If you were going to do this on Desmos, probably wouldn't be that helpful because you'd still have to calculate the slope, but you could pick an answer choice, plot it, and then pick out 2 points, and you could use the slope formula to figure out the slope, though I don't know, might not be as easy as just what we did here. Take your pick. Great. Okay, question 2. So I really like to, when they give you a fifth form, kind of like at the top, I like to just work with that. I usually find that's easiest. So let's do that. Ax plus by equals c. They want us to find the x-coordinate of the x-intercept. Remember, x-intercepts have y equals 0, y-intercepts have x equals 0. So since x-intercepts have a y of 0, we're going to replace y with 0 and then solve for x. So this guy goes away. B times 0 is just 0. We get ax equals c. And we get the x-coordinate of the x-intercept. We divide both sides by a, and we get x equals c over a. Now I'm looking at all the answer choices, and it is looking to me like the only one with a constant or coefficient of c over a is right here in answer choice B. So I believe that is the answer. Let's go to Desmos. Okay, so I just picked some really random constants, and I'm going to go and find the x-intercept. It says 5.66 repeating. Let's put that in there. We get 17 over 3. And now you can just kind of start guessing and checking. Like, okay, looking at answer choice A, I see a C over B. No, that's not that. I see an A over B. No, that's not that. I see a 5. That's not that. All right, let me try C over A. Then once you get to C over A, you realize that's 17 over 3. So that's another way you could have done it using Desmos. Okay, question 3. So we want to find the y-coordinate of the y-intercept. So I know I'm going to want y by itself, so I'm going to pick one of the ones with y by itself. So how about this one? And we're going to make x equal to 0 because that's true for all y-intercepts. So I'm going to do 4 times 0 minus 0.75 squared plus 5.75. Okay, negative 3/4, so 3/4 squared. That's 9/4, so 2.25. 2.25 times 4. Let me see here. Okay, 4 times 3/4, that's 9/16. times 4 gives you 2.25. 2.25 plus 5.75 is 8. So we get y equals 8. That's the y coordinate of the y-intercept. I'm now looking at all the answer choices to see which one has a constant on display of 8. And I see answer choice A is the only one. Let's do it on Desmos as well. Okay, they're all equivalent forms, so you can pick whichever one you want. And you see the y-coordinate of the y-intercept is 8. So you could just do that and then quickly scan the answer choices looking for an 8. Okay, question 4. So for this one, it says the minimum value of f of x. So that means we want to find, because these are all quadratic functions, we want to find the, it's all equivalent form of a quadratic. We want to find the y-coordinate of the vertex. So h comma k, so we want to find k. I don't know, doing it by hand is just kind of going to give away the answer. So I don't know, why don't we just do it on Desmos? Okay, question 4. I typed it into Desmos, and we're going to do 2x squared plus 1x plus 9. I just did answer choice A, they're all the same. We want the minimum value. The x value, where the minimum takes place, is -5, but the question wants the minimum value of the function, which is 9. So we're looking at all the answer choices for a 9, and that is in answer choice. We don't really care about the sign, so let me just highlight the number. So that is in answer choice D. If you knew from our basic quadratics video that vertex form is the form that showcases the min or max, you would maybe notice that answer choice D just so happens to look exactly like vertex form. So that would have been how you would have done it if you were going to do it by hand. Great. Okay, question 5. I always recommend you do these guys just straight on Desmos because you have to evaluate the function, and that can get really annoying to do by hand. Just make sure that when you go to type it in Desmos, at the very end, you put the domain restriction in curly brackets at the end of the function, just like we did in the slides. Let's jump to Desmos. Okay, so I just typed both these in. Now the question wants me to find the maximum value. So I noticed for both of them that the maximum is at the rightmost x value, in this case 0. So to find the maximum of both of them, I'm going to do, for f, I'm going to do f of 0. And for g, I'm going to do g of 0. And I get the maxes are 19.2 and 3.2 for each of them. So let's come back over here. And now I am looking, does f of x display its maximum? Well, I see we have a 19.2 right here. So choice 1 is looking good. And for choice 2, I don't really see a 3.2 anywhere. I see a 50, I see a 2.5, and I see a 3. So I think this one is no good. And I think the answer to this guy is going to be Roman numeral 1 only. Okay, question 6. We're once again going to go straight to Desmos. Just don't forget to put the domain restriction in curly brackets at the end. And we're going to be searching for the minimum value this time. Let's go to Desmos. Okay, so I graphed each of these functions with the domain restriction, and we want the minimum. So I'm like, looking at the red one, f of x first. I'm like, is the minimum on the left or the right? Well, it's on the right, and the rightmost x value is 4. So I'm going to type in f of 4, and I get 15. And then, oh, sorry, that's the blue. The blue is on the right. The red for f of x, I mixed them up, is the bottom is on the left, you see down here. So we're going to type in, it's 1 to 4, so we're going to type in 1, that's the leftmost x value. Okay, so we get 7.68. Then for g, the smallest the y value, the bottom is on the right, and the rightmost x value is 4. So I'm going to do g of 4, 12.8. All right, so both my minimums are 7.68 and 12.8. And let's come back over here. And okay, I see a 4, I see a 3, I see a 1.25, and I see another 3. So none of those are equivalent to 7.68. So this guy is out. Over here, I see a 5, I see a 2, I see a 0.8, and I see a 1. None of those are equivalent to 12.8. So this one is also out. So the answer to this guy is neither Roman numeral 1 nor Roman numeral 2. Okay, question 7. So once again, guys, just do not forget to put the domain restriction at the end. And then this time we are looking for the maximum value. Let's go to Desmos. Okay, I typed both the functions in, and now I'm just kind of looking, and I'm seeing for the red one, we want a max. So we want to go to the left. The leftmost is from 2 to 5, so the leftmost x value is a 2. So I'm going to type in f of 2. Okay, so that gives me 5.76. And then the blue one, you can see, oh, it's getting bigger as you go to the right. So we want the rightmost x value, which is 5. So I'm going to do g of 5. And I get 75. And I'm going to come over here and write both those down next to the answer choices. So 5.76 and 75. And it seems like there is a 5.76 in Roman numeral 1, so that's good. And it seems like there's a 75 in Roman numeral 2, so that is good. So the answer is answer choice C, choice 1 and choice 2. Okay, question 8. This is testing us on our understanding of advanced exponentials. The favorite form of the SAT for an advanced exponential is y equals a times b to the x over n, which I cover in my YouTube shorts. Anyway, so it says for each increase in the value of x by 8. Okay, so when x goes up by 8, that's telling me the interval. So n is equal to 8. The value of y increases by a factor of r. So that is telling me the multiplier. That is telling me b. So it's going to look something like this. Y equals a. We just established b is equal to r. And n should be 8 because it's an increase when x goes up by 8. So instead of n, I should put 8. So we want to get an answer choice that will look something like that. And I'm looking at them, and none of them really seem like they're going to give me that. Something I notice here is that these 7s, when I do power to a power rule, and I multiply 3/7 times 7/24, those 7s will kind of cancel. And 3/7 times 7/24 is 3 over 24, which is 1/8. So that this actually becomes 16 4 to the 1/8 x, or in other words, 16 4 to the x over 8. So whenever you do all these power to a power, you multiply the powers. That's rules of exponents. It's called power to a power rule. All right, so you can kind of see now, oh, all right, r, when the n is equal to 8, r is equal to 4. So now I'm looking to see where is there a 4 on display. And coincidentally, I just happened to pick the one with a 4. You see this 4 right here. So the answer is A. That might have been a little confusing. I'm going to show you that you can still figure this out purely by using Desmos. So let's go do that. Okay, just to show that this will work with any form you pick, I picked like the messiest one, answer choice D, because they're all equivalent forms for this question, right? And the question says when x increases by 8. So I'm going to do f of 0, and then 0 plus 8, is 8. So in other words, f of 8 is 64. Okay, so what happened when I increased x by 8? If I do 64 divided by 16, I see that it increased by a factor of 4. So that means r is 4, and then I would go and look at the answer choices and see that a is the answer. And just to drive this home to you guys a little bit further, I plotted those 2 points. So 0, 16 and 8, 64. And you see, again, when x goes up by 8, y gets multiplied by 4. It increased by a factor of 4. That's what they want us to figure out. The only answer choice with a 4 on display is answer choice A. Okay, question 9. So for this one, we got for each increase in the value of x by k, that's telling us the interval, the n. And then the value of y increases by a factor of 6. That's telling us the multiplier. And so it's going to look, we want it to look something like this. So y equals a. B, they told us the multiplier is 6. So I'm going to put 6 to the x over, and they told us the interval, it goes up by k. So instead of n, I'm going to put k. So we want it to look something like this. So naturally, I'm kind of gravitating towards the answer choices with a 6 as the base. So why don't I work with one of those? So how about I do answer choice D? I'm going to just rewrite this to look a little nicer. So 15, 7, 6 to the x over 14. So power to a power, you multiply. So 7, 6 times 1 over 14. That's 1/12. So this is going to be 15, 6 to the 1/12 x. And to write it like this even more, I'm going to do x times 1 is just x. So this is x over 12. And you guys can now kind of see that k is equal to 12. So that means 1 over k is equal to 1 over 12. And that's what the question wants, right? So we're looking for an answer choice that has a 1/12 in it. The only one that has that is B. So we're going to go with B. Let's go do it on Desmos as well. All right, so let's start over. I just went with a different answer choice. I think it's answer choice C. And we don't know the interval, but we do know the multiplier. We know we're going to be multiplying y by 6. So why don't we do what I did in the slide? So let's see what y is when x is 0. So that's 15. And then we'll do another y equals, we'll do f of 0 times the multiplier. So that's 6. So 90. And we'll see when that happens. So we went from y equals 15 to y equals 90. Hopefully you guys agree that's times 6, right? And x went from 0 to 12. So k is equal to the second, the rightmost x value minus the left one. So 12 minus 0, and we get 12. And that means 1 over k must be 1/12. And then I again look at all the answer choices and see that the only choice with a 1/12 on display is answer choice B. Okay, question 10. This is an airtight question. This is just meant to be a challenge question to get you thinking about the idea. A radical function, the SAT these days, they kind of expect you to know what that is a little bit, way more than they have in the past, right? There's been questions about radical functions before, so I want to include something different. Break up the monotony. All right, so just notice here before we go that the minimum value, so we're looking for the lowest y value. And it says, I'm going to do it by just inventing numbers. Invent valid numbers. That's a good problem-solving skill. We talked about that in the slides. So, but it says C is less than 0 is less than A is less than B. So I have to pick numbers that's true for. So I got to pick a negative C, a positive A, and then a bigger positive number for B. All right, let's go to Desmos. Okay, guys, I plotted this on Desmos. Note that I picked pretty random numbers and that I picked ones that satisfy the inequality. So I made C -2, I made A 3, it's got to be bigger than 0, and then I made B 7, it's got to be bigger than A. I'm looking at this graph and I kind of see, the lowest point is like over here, right? So I click here and I drag it, and it tells me that the lowest Y value is -2. That's the minimum value. And I noticed that, and I bet if I change the numbers, this would still be true. I noticed that that's equal to C. So we're going to go back to the whiteboard and we're going to look to see which one has a C in it. All right, so the one that has a C on display as a constant or coefficient is this one here. This probably wouldn't be an actual SAT question, but I'm going to highlight all the constants, hopefully make this clear for you. So we got an A, we got a B, and then we got a C. This top one, we have not a C, we have a constant of 4C, a constant of 3C. Neither of those are the minimum, right? It would have been like -6 or something. It would have been 6 instead of 2 in my example. So that's not equal to the minimum. We've got a constant of B, and we need a constant of A. In the second answer choice, we got a constant of 5C, a constant of 6C, a constant of A, and a constant of B. And I guess, in all these, we have coefficients of like 1 in front of X and Y, but that's really neither here nor there. So you see, it kind of looks like there's a C present, but there's not like a C present on its own as a coefficient or a constant. That only happens in answer choice capital C. Okay, everyone, thank you so much for watching until the end of the video. Please comment below your thoughts on the video and worksheet. Did you find them helpful? Be sure to like the video and subscribe for more digital SAT math content. And if you need tutoring, my website is linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.